Our moon, a celestial dance partner to Earth, marches to the beat of a different drum when it comes to time. Unlike Earth, where time is a constant rhythm, the moon offers a unique perspective on the passage of time. We are accustomed to the familiar cycle of day and night, a 24-hour period that dictates our lives. This cycle is so ingrained in our daily routines that we often take it for granted. But on the moon, time takes on a whole new dimension. The lunar environment challenges our conventional understanding of time, offering a stark contrast to the earthly experience. A lunar day, the time it takes for the sun to return to the same position in the sky, lasts a whopping 29.5 Earth days. This extended day-night cycle is a result of the moon's synchronous rotation with Earth. This means 2 weeks of sunlight followed by 2 weeks of darkness. Such prolonged periods of light and dark create an environment unlike anything we experience on Earth. This alone presents unique challenges for lunar explorers. The extreme conditions require careful planning and adaptation to ensure the safety and success of missions. Imagine a world where day and night are stretched to extremes, where the concept of a day takes on a whole new meaning. The lunar landscape, bathed in prolonged sunlight and shadow, offers a surreal experience. This is the reality of time on the moon, a reality that we must understand as we venture further into our cosmic backyard. The unique temporal environment of the moon will play a crucial role in future lunar missions and settlements. And the differences don't end there. The moon's gravitational pull, which is only about 1/6 that of Earth's, adds another layer of complexity to the lunar experience. Gravity, the force that governs the cosmos, also plays a fascinating role in the way time unfolds on the lunar surface. The reduced gravity affects everything from the movement of objects to the biological rhythms of potential lunar inhabitants. Understanding these differences is essential as we prepare for extended stays on the moon and beyond. Albert Einstein, in his groundbreaking theory of relativity, revealed a profound truth. Time is not absolute but is influenced by gravity. The stronger the gravitational pull, the slower time flows. This might sound like science fiction, but it's a fundamental principle of the universe. And it has real-world implications for how we measure time on the moon. The moon, with its weaker gravitational pull than Earth, experiences time at a slightly faster rate. While the difference is minuscule, it's measurable with our most precise atomic clocks. This difference in the flow of time, known as gravitational time dilation, means that a clock on the moon will run slightly faster than an identical clock on Earth. Now let's delve deeper into the fascinating concept of a lunar day. This is a topic that often intrigues both scientists and space enthusiasts alike. On Earth, our 24-hour day is determined by the time it takes for the Earth to complete one full rotation on its axis. This cycle of day and night is something we experience every single day. The moon, however, rotates much more slowly compared to Earth. This slower rotation has significant implications for the lunar environment. It takes approximately 27.3 Earth days for the moon to rotate once on its axis. This means that a single day on the moon is equivalent to nearly a month on Earth. Here's where it gets even more interesting. The moon's orbit around Earth also plays a crucial role in determining the length of a lunar day. The relationship between the moon's rotation and its orbit is a key factor. The moon takes about 27.3 days to orbit Earth, which is the same amount of time it takes to rotate once on its axis. This synchronization is not a coincidence but a result of gravitational forces. This synchronous rotation, where the same side of the moon always faces Earth, is why we only ever see one side of our celestial neighbor. This phenomenon is known as tidal locking. Because of the moon's orbit, it takes an extra 2.2 Earth days for the sun to return to the same position in the lunar sky. This results in a lunar day that lasts 29.5 Earth days. This extended period of sunlight and darkness has profound effects on the lunar surface, influencing everything from temperature variations to potential human activities on the moon. Lunar timekeeping, a necessity for exploration. As we venture back to the moon, this time to stay, establishing a standardized lunar time system is no longer a luxury, but a necessity. Imagine astronauts on different missions, separated by vast distances on the lunar surface, trying to coordinate their activities without a common reference of time. The potential for confusion, miscommunication, and even safety hazards is significant. A unified lunar time standard would provide a common temporal framework for all lunar operations, from planning missions and coordinating rendezvous to conducting scientific experiments and managing daily activities on a future lunar base. Challenges on the lunar surface. gravity wells, and temperature swings. Establishing a lunar time standard, however, is not without its challenges. The moon's uneven gravity field, caused by variations in the density of its interior, means that time will flow slightly differently depending on location. Additionally, the extreme temperature swings on the lunar surface, from scorching heat during the day to frigid cold during the night, can affect the accuracy of clocks. These are not insurmountable challenges, but they require innovative solutions. Atomic clocks and lunar GPS, keeping time on the moon. Fortunately, we have the technology to overcome these challenges. Atomic clocks, the most accurate timekeeping devices ever created, can measure time with incredible precision, accounting for even the subtle differences in the flow of time caused by the moon's gravity. These clocks, combined with a network of lunar satellites, similar to GPS on Earth, could provide precise time and location data across the entire lunar surface. This lunar GPS system would be essential for navigation, communication, and coordination on the moon. One giant leap for timekeeping: international collaboration for a lunar time standard. Just as we came together as a global community to explore space during the Apollo era, establishing a unified lunar time standard requires international cooperation. The Apollo missions were a testament to what humanity can achieve when we work together, transcending borders and differences. NASA is leading the charge, working with other space agencies and scientific organizations to develop a system that meets the needs of all future lunar missions. This collaboration involves sharing knowledge, technology, and resources to create a timekeeping system that is accurate and reliable. This is not just about keeping time on the moon, it's about creating a synchronized framework that will allow for seamless operations and communication between different missions and countries. It's about establishing a framework for collaboration, ensuring the safety of future lunar explorers, and maximizing the scientific return of our lunar endeavors. A unified time standard will help in coordinating activities, conducting experiments, and ensuring that all data collected is accurately time-stamped. A unified lunar time standard is a crucial step in our journey to become a truly spacefaring species, paving the way for a permanent human presence on the moon and beyond. This initiative will not only benefit lunar missions but also set a precedent for future interplanetary exploration, ensuring that humanity can explore the cosmos in a coordinated and efficient manner.